Hello and welcome. In this video, we're going to be discussing how to solve a compound inequality. So our inequalities are either going to be joined by the word and, as in this case. The other possibility is that our inequalities are joined by the word or. So before we begin solving this first problem, let's talk about the difference between and or. So and means that both conditions must be met. So if we look at this first example, x is greater than 4 and x is less than or equal to 7, really what we're looking for are the numbers that satisfy both inequalities. In other words, which numbers are both greater than 4 and at the same time less than or equal to 7. So to find those numbers, let's graph out each inequality separately. So the first one, x is greater than 4, I would start by having an open circle at 4, and then graphing all the numbers to the right. The second guy, x is less than or equal to 7, I would start with a closed circle on 7, and then graph all the numbers to the left. And so you'll notice that my number line has basically been broken into 3 sections. So if we look at the first section of numbers, notice all of those numbers are in the red set. They're not in both sets because the green set doesn't start until 4. These numbers only satisfy one condition, and specifically those numbers are all less than or equal to 7. So I don't want to include this section because these numbers don't meet both conditions. If we look at the middle section, those are exactly the numbers we're looking for because you'll notice that those numbers are both in the red set and in the green set. In other words, these are the numbers that are greater than 4 and at the same time less than or equal to 7. If we look at the numbers to the right of 7, well, we sort of have the same problem as in the first situation. These numbers are only part of the green set. In other words, they're part of the set of numbers that are greater than 4. So since they don't meet both conditions, we wouldn't want to include this section in our answer. So how would we express our answer? Well, I certainly don't want to include all the numbers on the number line. I just want to include those numbers that meet both conditions. And as we saw, those are the numbers between 4 and 7. So if I were graphing out my solution would look like this. I would have an open circle at 4, and then a closed circle at 7, and then I would want all the numbers in between. If I were expressing my answer in interval notation, I would start with my left endpoint, which is 4, and because I don't want to include 4, because I have an open circle, I would use a rounded parenthesis. And then my right endpoint I do want to include, there's a closed circle there, so I would have a square bracket for 7. So that would be my answer in interval notation. So let's look at or. When we use the word or, we really mean only one condition must be met, or more accurately, at least one condition must be met. So let's look at this example. We've got x is greater than or equal to 2, or x is less than or equal to -1. So I'm going to start by graphing out each one of those sets individually, just like I did with the and case. So I've got -1, I've got 2. If I graph out the first inequality in red, x is greater than or equal to 2, I'd have a closed circle at 2, and I'd graph all the numbers to the right. If I do x is less than or equal to -1 in green, closed circle at -1, graph all the numbers to the left. Okay, now my interpretation is different than it was in the and case because I want any number that meets at least one of my conditions. So again, my number line's been split into 3 sections. If I look at this section to the left of -1, notice those numbers are all part of this green set. What does this green set correspond to? Those were all the numbers that were less than or equal to -1. So these numbers all meet one of my conditions. That means in my answer, I would want to include all of these numbers. What about in the middle? Well, in the middle, notice these numbers are part of neither set. So they meet neither one of my conditions. So I'm not going to include that in my answer. The numbers to the right of 2, well, again, I want to include those numbers as part of my answer because they do meet one of my conditions. Those numbers are all part of this red set, and the red set corresponded to the numbers that were greater than or equal to 2. So what does my answer look like in this case? Well, it looks a lot like what I just graphed when I did each one individually. It's going to include all the numbers to the right of 2, including 2, and all the numbers to the left of -1, including -1. In interval notation, notice I have 2 separate intervals, and there's a gap. So I've got an interval over here, an interval over here, and there's a gap in the middle. So that means when I describe this with interval notation, I'm going to use 2 separate intervals with a union symbol in the middle. So if I want to describe this first set, well, the left endpoint, notice the arrow's pointing to the left endpoint stretches on to infinity in the negative direction. So I'll have negative infinity. And then the right endpoint is -1. And again, since there's a closed circle, I'm going to use the square bracket with the -1. With infinity, positive or negative, I always use the rounded parenthesis. So that describes that first set. So that describes this set. This set, the left endpoint is 2. And since I want to include 2, I'm going to use the square bracket. And that set stretches on to positive infinity. So I want to join those 2 intervals together because they both should be included as part of my answer. So I use a union, or a U, to join the 2 intervals together. Okay, so let's see how these 2 things play out in the problems that we did, or the problems that we were going to look at the beginning of this video. So for the first one, all we're going to do is solve each inequality separately, and then we need to pay attention to how the 2 inequalities are joined together. So in this case, it's what I call an AND case. So our first step, step 1, is just to solve each inequality separately. Okay, so I've just rewritten our 2 inequalities. So to solve the first one, I'm going to add 1 to both sides. That gives me 4w is greater than 24, divide by 4, and that gives me w is greater than 6. The second one, add 1 to both sides. That gives me 3w is less than 30, divide by 3. That gives me w is less than 10. And again, the word that joins our 2 inequalities is AND. So now I'm just going to do exactly what I did in the background section. I'm going to graph each one of these inequalities separately, and because the word in the middle is AND, I'm only interested in numbers that meet both conditions. So we've got 6, we've got 10. If I graph the first set in red, w is greater than 6, would start at 6 and would include all the numbers to the right. If I graph the second set in green, would start at 10, would include all the numbers to the left. And now I'm interested in only the numbers that meet both conditions. So if I look at my number line, again, notice it's been split into 3 sections. This section of numbers are only in the green set. This section in the middle are in both the green and the red sets. And then the section to the right, those numbers are only in the red set. So again, because this is an AND case, I only want the numbers that are in both sets. So that would be this middle section. So my answer, if I were doing interval notation, my answer would be left endpoint 6, right endpoint 10, and I'm using the rounded parentheses here because I don't want to include either one of those endpoints. If I were graphing out my solution, I would have 6, 10, open circle at 6, open circle at 10. Okay, so here's another one for you to try. Pause the video and then restart it after you've given it a shot. Okay, so again, our first step is let's solve each inequality separately. So that gives us 2w is less than or equal to 2. And then divide both sides by 2. W is less than or equal to 1. If we do the other guy, we get 3w is greater than 9. Divide by 3. W is greater than 3. And again, the word and joins our two sets together. So then our second step is just to graph out each inequality separately and then take the intervals, interval or intervals of numbers that meet both conditions. So we've got 1, we've got 3, and if I graph out the first set in red, w is less than or equal to 1, closed circle on 1, and I would graph out the numbers to the left. W is greater than 3, I'll do in green, open circle at 3, graph the numbers to the right. So this is a really interesting case because if I look at my number line, which has been broken into 3 pieces, notice these numbers are in one set, but they're not in both. These numbers are in neither set, and these numbers are only in my green set again. So which numbers are in both sets at the same time? Well, in this case, none of them are. So my answer would actually be what we call the empty set. There are no numbers that meet both conditions at the same time. Okay, so let's look at the OR case. So our steps are going to be the same. The only difference is how we interpret each inequality and join them together. Okay, so our first step, let's solve each inequality separately. So add 1 to both sides here. And then divide by 3. That gives me w is less than or equal to 5. For this guy, plus 2, 7w is greater than 35. Divide by 7. We get w is greater than 5. So then from there, again, these two inequalities are joined by OR. So let's graph each one separately. Well, notice this time I have a really interesting case because I actually kind of have only one sort of key number on my number line. So the first one, w is less than or equal to 5, I'm going to do in red. So that would be closed circle, all the numbers to the left of 5. The other one, w is greater than 5, open circle at 5, and then all the numbers to the right. So now if you look at my number line, it's broken into 2 pieces. Remember, since it's an OR case, I want any section of numbers that meets at least one of my conditions. So if you look at the numbers to the left of 5, all of those numbers are in my red set. That means they've met one of my conditions. So I want to include those in my answer. What about the numbers to the right of 5? Yep, those have met one condition as well because those guys are all part of my green set. What about 5 itself? Well, because I have a closed circle right here, those numbers, or excuse me, that number 5 is also part of my red set. So that means it's met one of my conditions. So what's my answer here? Well, my answer would actually be every single number stretching from negative infinity to positive infinity. So if I were drawing it out, it would just be one solid number line with arrows at the ends to indicate that I'm stretching on to infinity in both directions. In interval notation, my answer would be left endpoint negative infinity, right endpoint infinity. It stretches off to infinity in both directions. Okay, so here's another one for you to try. Pause the video and then restart after you've given it a try.